Have you ever wondered how pollutants seem to magically disappear from water, or how certain materials can effectively clean it, almost like a natural filter? Well, the fundamental understanding of the sorption process is that it describes how one substance accumulates onto the surface or into the bulk of another substance. It is a critical natural purification mechanism that influences water quality and the fate of contaminants in aquatic environments. The core mechanism behind sorption involves various physical and chemical interactions between a sorbate, which is the substance being taken up, and a sorbent, which is the material doing the taking up. For instance, adsorption, a major type of sorption, occurs primarily on the surface of the sorbent. This happens due to intermolecular forces like van der Waals forces, electrostatic attractions, or even specific chemical bonding at active sites on the surface. Another form, absorption, involves the sorbate penetrating and being distributed throughout the entire volume of the sorbent, often seen in materials like hydrogels swelling with water. To apply this understanding, consider how engineers design water treatment systems. By selecting sorbent materials with high surface areas, such as activated carbon, and specific chemical properties that attract target pollutants, they can efficiently remove contaminants. For example, understanding that certain organic pollutants are hydrophobic can lead to using sorbents that have a strong affinity for such compounds, effectively drawing them out of the water phase. This knowledge guides the choice of filter media for municipal water plants or industrial wastewater treatment. A key insider detail to grasp is the concept of a sorption isotherm. This is a mathematical model that describes the equilibrium relationship between the amount of sorbate adsorbed onto a sorbent and the concentration of the sorbate in the surrounding solution at a constant temperature. Studying these isotherms allows scientists and engineers to predict how much of a contaminant can be removed by a given sorbent, which is invaluable for designing efficient treatment processes and assessing environmental risks. Ultimately, understanding sorption means recognizing that the removal of substances from water is not random but governed by predictable physical and chemical interactions. This allows us to predict the movement and fate of pollutants in natural systems and to engineer effective solutions for maintaining and improving water quality, turning complex chemistry into practical applications for a healthier environment.
If you love learning about water, like, subscribe, and keep exploring with us.